Welcome to Study Loop.
In this problem, we're given the wavelength of a photon, and we're asked to determine whether it is a photon with gamma ray energy that would have originated from the nucleus of an atom, or whether it's a photon that came from an energy change of an electron in one of the orbitals. In order to determine the energy of a photon, we use from quantum mechanics the relationship energy equals Planck's constant times the frequency of that photon. And for this problem, we are given the wavelength of the photon in question, of 1.15 times 10 to the negative 13th meters. In order to find the energy of that photon, we're going to have to convert this somehow, this wavelength, to a frequency. And we'll also need to know Planck's constant. I've looked it up in terms of joules, and you can also find it in terms, or rather joule seconds rather. You can also find it in terms of electron volt seconds, which I've written here. So in order to find this energy now, we can use the same relation, but if you'll recall that wavelength times wave frequency equals wave speed, we can determine this wave frequency as the relationship, by dividing the wavelength by the wave speed, or rather the wave speed by the wavelength. And that is the equivalent of, well, let me write it out here. C, the speed of light, is equal to the wave frequency times the wavelength. So basically, if you divide this wave speed by the wavelength, you end up with a wave frequency, which we can substitute in this equation for the energy of a photon. Doing this, we can write out this equation in full. We know in the denominator we have our 1.15 times 10 to the negative 13th meters. And in the numerator, we have our electron volts version of Planck's constant. To the negative 15th. And we need our speed of light. And we're jumping the gun here, forgot my units. These are electron volts seconds times the speed of light, which we will take as 3.0 times 10 to the 8th meters per second. Plugging in those numbers, you will find that the energy of the photon in question is equal to 10.79 mega electron volts. That's 10 to the 6th electron volts. Only gamma rays have energies this high, and gamma rays can only originate from a nuclear process. They are not the result of an energy level change of an orbital electron. So that answers our question. Photon originated from a nuclear process.